for any given surface, we've been introduced to the idea of a partial derivative. And in this case, if I have a point on some sort of surface, what I can think about is I can think about the partial derivative in the x direction or the y direction. We can go along this I vector or along this j vector. But the problem might be is that I can go in any direction on a surface, so how do I describe a derivative, or at least its value, along a particular direction, as opposed to just going in the x direction or just going in the y direction? Effectively, how do I find the value of the derivative along that red line there? So I want to know how quickly it's changing in that direction. Very common thing that happens in dynamics of aircraft, for instance. You don't necessarily want to know your north or east. You might want to know along your heading or along your, whatever. Anyway, so we can do this, and it's surprisingly not that hard. So if I have some sort of unit vector that's, this described by, has a component AI plus BJ, those are my components, then the way that I get the value of the directional derivative is I take the partial with respect to x, and I multiply it by the first component, and the partial with respect to y, and I multiply it by the second component. And if you think about it, that makes sense, because these are, since it adds up to unit vector, you can think of it almost like weights, like some percentage in this direction and some percentage in that direction, and you just take the percentage associated with that component and multiply it. So I have some percentage in the I and some percentage in the j, and every vector is some percentage along that way. And that's the idea. That's the whole point. And what might make that even more easy to understand is that if I have the unit vector written in the terms of cosines and sines, so you can think of it as some arbitrary angle, I guess, if in this case, some arbitrary angle, what you see is you just take the cosine of the angle times the x direction and the sine of the angle times the derivative in the y direction. One last little piece, though, is that if you're not dealing with unit vector, this only works for unit vectors. So if you have some arbitrary vector v that you're looking to go in its direction, you need to normalize that vector, or rather just divide it by its magnitude before computing this, or your directional derivative will be scaled incorrectly.